Okay, great. Thank you very much. Today I'm going to talk about 5G multi-site deployment using OSM. My name is Sergio Tarazona. I'm from Whitestack. Okay, this is the agenda. First, we're going to see a little introduction. Then we're going to move to the architecture of 5G network deployment. Then we're going to see a demo. Then we're going to talk about the next steps, and finally, if there's time, we'll have some questions. Okay. Um, ONI has several years of experience working with radio access network and core network technologies. Also, they have an active community working on delivering new functionalities like Open RAN, network slicing, etc. Whitestack has deployed the full 5G ONI core, including elements like AMF, SMF, UPF, UDR, UDM, and RF. And Whitestack is trying to deploy ONI from OSM in an automatic way with primitives to allow users to perform operations from day one and day two. Okay, this is the architecture of the 5G network deployment. We have in the middle part the 5G core. It's over a Kubernetes cluster based on white mist. Here we have the control plane with the UDM, UDR, AUSF, NRF, AMF, SMF. We have also the user plane part with UPF. And this is connected to the access part. In this case, we're using GNB and UE simulators. GNB sim is called. And in the other part, we have the data network. This is an external server that is going to be used for testing. Okay, we're going to test the connectivity between this access to these external servers passing through this UPF, this core actually. In the middle, we have a router to make the connectivity between these three beams in this case. Okay, so we'll deploy the 5G ONI core KNF. This will be a KNF for the 5G core. Then we're going to deploy the access GNB SIM, in this case, in one different beam, and the external server in a different beam. So all of these three packages, BNF, KNFs, are going to be in different beams. That's the intention of this demo, to demonstrate that we can deploy in a different beams, so could be multi-site, could be a multi-site deployment. And all of these three packages are going to be called from this network service package. Okay, we're using Helm-based execution environments to define primitives for day one and day two in the BNF. For day one, for both GNB SIM and external server, we need to install Docker components and copy configuration files in the network function as part of the instantiation. And for day two, we're going to have primitives to start and stop the application service at any time. In addition, we can send any command to the bash of the network function using SSH. It's important to remember that Helm-based execution environments allows us to interact with the network function via SSH, netconf, REST. It depends on what the NF has available. And also Helm-based is one of the alternatives we have available for primitives for execution environments. Okay, about the demo, first we're going to run this ns create command for both KNF and BNFs in different beams. In this case, the first part is like like we all know, the second part, we're going to use the config to set, in this case, the SSH key is for having connectivity between my VM in order to connect to the BNFs to test. Then we define the namespace of the 5G core, in this case is ONI, and then we define the beam accounts for the GMB SIM and the external server. Those are different if you see it. So as I mentioned before, we're going to have in one beam the KNF and a different beam the BNF packet, the GMB SIM, sorry, and in other beam we're going to have this external server. Okay, so let's move to the demo, and then we're going to see the descriptors and primitives created for this deployment. And then we have to wait for the NS to be ready in the OSM environment and in the cluster to see the 5G core creation. Then we're going to use OSM to start the service for GMB SIM and external server. And finally, we're going to perform iPerf test from the GMB SIM, from the access to the external server to see that everything is working fine. So first, I'm going to, this is the OSM that I have. So in this case, I'm going to run the ns create command. There it is. So it's building. Here I have the cluster, so I can see the creation of the 5G core. In addition, I can see in the beam, in the OpenStack beam, the GMB SIM and the external server are created. But since there is execution environments running, so we need to wait a little bit to have it ready. In the meantime, we can see here in the open source MANO the descriptors. Okay, if I see the packages, I have this NS package. So this is the 5G core. And here I can see that I have this GMB SIM with two interfaces, one for management and one for data. I have the external server here with management network and data network. In this case, the IPs are fixed. And finally, I have this 5G core KNF. Okay, so the BNF packages, I have the KNF. In this case, it's pretty simple because I have all the 5G core packed in one Helm chart. Then I have the GMB SIM here, where, as you can see, I have these day2 primitives to start the service, to stop the service, and send any command. This is for GMB SIM. And also I have the initial config primitives for day one, where I have this run script to install Docker and some components and copy the configuration files to the network function. In the same way, we have for external data network, day one, day two, sorry, to start, stop, and to send commands. And for day one, the primitive to install the packages needed for the network function and copy some configuration files. Okay, okay, great. I have ready the network service, so that's good. So I'm going to check here. We have it ready here. We can see here in the Kubernetes cluster that I have ready the 5G core. So now I'm going to connect to the VNFs. In this case, it's an SSH to the GMB SIM. That's good. And I'm going to connect to the external server. Great, I have connection now. So finally, I'm going to start the iPerf server in the external server. I'm sorry, I forgot to start the service. So here in the OSM, I can execute the primitive, in this case, the VNF. Let's start for external server. We have 3. I'm going to start the service. So I'm going to type here. That's it. In the same way, I'm going to start the service for the GMB SIM. In this case, before I do that, we can check the logs in the port to see the connection of the GMB. So I'm going to send this starting command. That's it. And here we can see in the OSM that I have this running action. So that means that there's some action running in the network service. Okay, so we have to wait a little bit because an image has to be downloaded in the VNF, and that's it. That's starting to connect. And here I have you can see it here in the GMB that is connected. The GMB SIM is in healthy state. And also I can see in the logs of the AMF in the 5G core that the GMB is connected and the UE is registered to this GMB. Okay, so I'm going to start the perf. That's it. And I'm going to test it from the GMB, from the UE. As we see here, this is the bitrate. It's almost 285 megabits per second. So that's it. Our 5G core is working good. So if I go to the OSM, I can stop this DGMB service because I finished testing. That's it. And here I can see that the UE is deregistered from the 5G core. Okay, so it worked as expected. So the next steps, we're going to deploy the router. As I mentioned in the architecture, there's a router. Currently, it's not configured from OSM. We're going to do that in the next step. And we're going to use a BIOS router. Also, we're going to divide the 5G core in multiple KDUs per each NF. As you saw, currently is one packed Helm chart, so we can divide it and have multiple KDUs. In addition, we're going to create primitives for 5G core KNF. We're going to see how can we send commands to this KNF. We have to explore that. Then we need to test additional access network functions, could be BNFs or CNF. In this case, was one BNF called GMBSIM, but our intention is to test with more access network functions. And finally, we're going to create an UPF in an edge site. Currently, all the ONI is running in just one Kubernetes cluster. So to have one network function in a different site, we need to see the implications of having this kind of configuration. So that's the next steps. And that's it. Thank you very much for your time. And I don't know if we have time for some questions, but thank you very much.
Thank you, Sergio. I think we can take some questions before we wrap up for the day.
Yeah, sure.
Okay, if there is no other questions, so I can just ask one quickly.
Yeah,
Yes.
sure.
I like your presentation. It's really very nice, and it answered actually one of my previous questions about like having more than one 5G test bed connected to like a central management system. So my question here is, have you evaluated the scalability of the system by like including more user equipment, like 1,000 user equipments, similar to some simulators who actually generate traffic loads for user equipments, and you connect this to the G node B to see how the system works with in real, almost like similar to the real time when you have more user equipments connected to the G node B. So have you evaluated the scalability of the system, a scenario like this?
Yes, I mean, we know that these kind of tests are necessary because we need to test the 5G core with in a real scenario with multiple users and multiple GMBs. That's why we have in the next steps these test additional access network functions, because currently GMBSIM it's like having just one user attached to one GMB, but as we know, we have open source solutions that can allow us to test multiple users connected to one GMB and sending traffic. So that's the next steps that we are considering for this deployment.
Okay. Yeah, I was just asking this question because we have a similar scenario like this actually in our lab. So there are some open sources that can generate like thousands of user equipments traffic. So you can evaluate your solution, the scalability of your solution in real time. Yeah.
Yes. Definitely that's the next steps that we need to test with this 5G core.
Okay. Yeah. Thank you.
We had one